going to use a tutorial which we use at AArt for interns and newcomers. Just a quick exercise on how to launch a very simple app, both backend and then deploy it on a front end. So what I would do is discuss some concepts first, but I'm going to make some assumptions, which I'll explain in a moment. And then I'll go through step by step what it is that we're doing and what we need to be aware of. I was actually trying to get the front end functioning. It sort of needs a bit of maintenance, but we'll see how far we can get. The important part is we see how it's deployed onto the secret mainnet, and then how you can then interact with your smart contract from the front end. Without further ado, I'm going to share my screen. You guys let me know when you can see my screen.
All right, looks good. We see, oh, perfect. I can see your code.
Perfect. So I'll just go through some main concepts. So I'm assuming that at this point you've already got a local smart contract. So you've made your you've got your Rust project and you've got your smart contract, and that compiles. And to do is you want to actually load it onto the secret network, and then you want to instantiate it, and then you have a front end here which you want to connect to that on the actual secret network. What I'm going to be using is, so in this env file, which is very important, so just to take a look at the file structure that we tend to use in at AArt, we have the root folder, so here, and then we have the backend, front end. Here, what we have is a series of build scripts, and well, yeah, they're all mainly scripts and make files, things that will help us build both the back end and the front end quite nicely. We use this at AArt, but we're going to do actually what you would do without this framework. So the first thing we want to do is, if I just go into the back end here, so we're assuming that on the back end, I'm just going to hide this. We're assuming that on the back end, our it's a nice little smart contract. It builds fine. We've tested it as well. It tests fine. We've done all our checks, and we're happy with the way our smart contract is. We're ready to deploy. The first thing we want to do is compile it down to WASM32. So the way that we do that is we run this command, which is actually inside this makefile here. So what we want to do is we want to compile for WASM32 unknown unknown. The way we do that is we use this command here, and if you don't have this target, the way that you can install it is using rustup. So what I would do in my situation is, familiar with cargo, you'd type you'd run that, but mine is obviously up to date. The first thing we want to do is create a .wasm file. So it'll be created in here, but we want it in our backend. So what I'm going to do is, if I head back here, and towards the end of this, I'm going to show you some ways that we do at AArt that makes this much nicer and less intimidating. We're going to just let that compile for a bit. Yep, that's finished. And inside our target release, we are going to, what we're looking for is there it is. This file here. This is our .wasm file. So this is fine, but what we actually want to do is two things. First of all, we want to take it out of, we want to copy it into just our backend file so we can sort of access it a bit easier and not go all the way into target. And then once we have this WASM file, to do is actually optimize it. And by optimizing it, we make it much smaller. And this means that when we load it onto the smart contract, it's a much smaller file, and that's generally better for uploading something. You don't want to upload a large smart contract. It's going to be more expensive when you upload it, I believe. So what I'm going to do is actually copy this. So we target release. Release. Oh, you can see. Well, I'm just going to cheat here and actually here. So this is effectively doing the same thing. We can see what this actually runs. Here we go. Okay. I cheated a bit because I don't want to learn the file structure in Target. But what we've basically done is the same thing, and then we've moved this into our backend directory. And we now have this contract.wasm.gc. What we want to do to this now is to optimize it. So when we optimize that, what we're using is let's head over here. Yeah. So Secret Network has a Docker image called Secret Contract Optimizer, and that helps us to optimize our smart contracts here. So if we run this, I'm going to run this just by running the make file. If you're familiar with make, then what I'm essentially doing is from the root directory in Loyalty app, I'm calling make, and that's effectively calling this inside this make file here. So what this is going to do is it's going to run this secret contract optimizer image, and it's actually optimizing this. So when we're finished, we have an optimized version of it. The next thing we want to do is actually load this this WASM file into the secret network mainnet. Now, this is where an .env file is quite useful. If you're familiar with .env, it's just it's a place for all of your environment variables to go. So you'll notice I'm using the testnet. This is it's the exact same thing as if we were doing it on the mainnet, except this would be secret 4, and then we would be using one of the actual mainnet endpoints. The reason why I'm doing it is because this is for demonstrator purposes. I don't really want to put something on the mainnet right now. And another thing is, obviously you can see this mnemonic. This is just a dummy account that we're using for demonstrative purposes. If you are going to use your env file, and I'll explain later why we've got this mnemonic when we want to run a script to load it. Do remember that obviously this is not a safe way to store it. I'm only doing this for demonstrative purposes. What I would recommend is actually this in the terminal itself. So this isn't going to be the env file, but you do this within the terminal. And then when you run anything that needs to use this mnemonic, it knows it from there. Just in case you do have any information that's private or you don't really want to upload onto GitHub, if this is going to be uploaded onto GitHub, remember to put it into your .gitignore. But yeah, for testing purposes, this is fine. So this .env file, this is what we're going to use throughout the rest of our uploading onto Secret Network. So the first thing that we want to do is to load the contract. I've got this TypeScript file called load contract, and that's going to sort of explain or explain a little bit what we're doing. So we want the WASM bytecode, and that's what we've just created inside backend, right? This is what we're uploading. So we provide the path to this. This is from the root directory. And what we're doing is we're storing the code onto the secret network. So we want to run this transaction. And I'm using Secret.js right now. So it's Secret.js is a very useful tool for when you want to do things in TypeScript or JavaScript. So this transaction, when I run it, that's going to hopefully load the contract. And if it fails, then we're going to get some output. What we want to retrieve from this transaction is a code ID. What I'm actually doing in this script is I'm using another useful tool called update.env. This is available as an npm package. So what I'm then going to do is when this transaction succeeds, I want to retrieve the code ID. Code ID in my .env file. I want to update a variable called the code ID because I want this later for the front end. So this value, after loading the contract, will hopefully be populated. Let's give that a try. Another thing which I have is obviously if I want to run this load contract TypeScript file, I've put that as a script in my actual in my root package.json. I'm assuming that some of you will be familiar with this because you're developers. So this is quite some useful tips to sort of make things a bit easier. So if I run npm run contract, there we go. So the contract is loaded, and we've been given back a code ID. So you want to keep track of this code ID because it's quite important. So we'll also notice that inside our .env file, the code ID has been populated. So the next thing we want to do is actually instantiate our smart contract. So the way we do that is we take this code ID and then we need to give our instance of the smart contract a name, and it needs to be unique. So we're just going to go with, I've actually done a second run of this, so it will complain if I don't name it something else. So I'll call it 2. We need to give it a name, and then we need to provide the code ID. And then using this, using this mnemonic, which is associated with this secret count, we'll be able to, if I go into here, instantiate contract, we'll be able to create an instance of this smart contract. And the owner of that instance will obviously be the wallet address that you use. That's quite important or later on when you want to migrate. If you want to support migrations, I believe you want to, there is a way that you can do that, but I think that'll be available on the Secret Network docs. But the important thing to note is that the address that you instantiate this contract with is sort of like the parent or owner of that instance. So label is going to be the name, and I always put the version as well. We want to supply the code hash. So this code hash, did we produce that? So we can retrieve the code, we can query the code hash using the code IDs. That's effectively what we're doing here. So we want the code ID that we've just retrieved, and then we get a code hash from that, and we also provide our wallet address. So if we now run this, npm run.
And Yesha, for your mainnet contracts, have you made them migratable?
Yeah, we've made them migratable, that's right. So a really important thing is, especially if you're deploying onto Mainnet and you want users to use it immediately, if you need to publish an update, an important update, without starting from scratch, because you want to preserve the state of your existing users of the contract. A migration is really useful. You won't lose that state, the state of your actual contract, while still pushing those updates. So yeah, that's an important thing to note, to make sure that your smart contract is migratable, which is quite easy now. It's pretty much the same as other Cosmos smart contracts. Sorry, Cosmos smart contracts. So we've just instantiated our contract. Now, what we retrieve from instantiating it is the actual contract address. This is something that we want to store as well. So I've prepared this script to also store in our .env file the contract address. And what I also find useful is to just keep hold of the instantiation hash, the actual hash itself of this transaction. So in our contract address, it's been updated. So if this was on Mainnet, then right now your smart contract is live. It's on Mainnet. The next thing to do is just to connect to front end. What we do is, so all you need on the front end, so we use Secret.js, and what you need in order to connect to the front end and interact with your smart contract is again, the code ID, the contract address, and then I believe you also want the code hash, but just like we did here, where did we go? Just like here, that's queryable. The reason why you want a code hash is when you want to perform queries against your smart contract, it's much faster. So it's much slower if you don't provide a code hash. So it's always recommended that you also retrieve the code hash from your front end. Our front end is just a simple React project. So we just have a constant, and then what will happen is, so this stuff is auto-generated. When I run a makefile, it will actually create these values by reading from the .env file. So what we want is the code ID. The chain ID will obviously, because this is on mainnet, it's going to be secret form or something like that. We want to provide an endpoint with which to interact with the smart contract. It'll be a mainnet one in the case of mainnet. This is some other stuff which is sort of as part of this app. So let's run it and see if it works, hopefully. So try and build the front end. It's a little outdated, so there's no guarantee if it works. It does. We'll be able to demonstrate that we can now interact with our smart contract. Okay. Okay, well, I guess not this time around, but the important part is we've now loaded our smart contract to secret, in this case testnet, but for your case it would be secret mainnet. We've created an instance of that smart contract. So our contract only becomes live once it's instantiated. And when it's instantiated, you're provided a contract address for that instance of the smart contract. And you are also provided the code ID from when you loaded it. These two are the main important things to hold on to. If you want to perform a migration in the future, you need both the contract address, and I believe you ideally need the code ID as well. Yeah, that's how you can upload. That's how you can launch onto secret mainnet once you've completed your smart contract on here. And then what's left is to connect to front end using Secret.js and start developing further on. That's pretty much it on my side. I'd ask if there are questions.
Awesome. Thank you so much for that presentation. Um, I guess one thing I think that's probably exciting for people to hear, who are going to listen back to this, is just about your experience, like actually building dApps that are being used in the secret ecosystem. So, could you just talk about some of the dApps you've been working on that are now launched, like Secret Casino and GovDAO, and what that process
Yeah.
has been like?
Yeah, so I'll look at it from two angles. So for AR Labs, that's our in-house stuff where it's a little bit more a controlled environment where we can say, okay, this month we want to push out a couple of sprints. We want to update some of our applications, such as Secret Casino. So this is an example of something we've built. This is entirely on the Secret network, and the way that we develop when it's in-house, when it's secret, when it's AR Labs, it's very much do a couple of sprints on the back end, and then see how it works on a test net. So we are often doing switching out these .env files for mainnet and testnet versions. So for like a couple weeks on end, we'll be working on, for example, Secret Casino on a testnet. We're trying lots of different things because we want to experiment. What can we do on the back end to make this user experience as good as possible? So we play around with a lot of things. And what that requires is, again, to mention, a lot of migration, because we don't want to create a new instance every time we want to try a new feature or fix a bug. So a lot of our stuff is very much, for this reason, that's why we have this structure where everything can be done using make files, because we'll change some things in the back end, and then we will run something like make build backend, and then we have another thing called build script, and that actually is it there? I think it's in another project. That actually does everything. So it builds the backend, it tests it, it uploads it, loads the smart contract, instantiates it or migrates it depending on a flag, and then it will actually load it. And if it's on, then it will actually produce the front end, and that can all be done from in one go. And the idea of that is, if someone pushes a change onto GitHub and they say, "Hey, check this out," but I want to test it on my own local machine. Let's say I want to test it on my local secret. That's something that we often do. Whereas when we're working with clients like with GovDAO, that's a bit more regimented, where we're working against it's less relaxed. So we're working against a roadmap where, okay, we have a meeting with the GovDAO team on let's say next Wednesday. We said by next Wednesday we'd be able to show them something. So what's really important for us is to go a bit more iteratively and a bit slower, and that very much requires sometimes having multiple instances, because we have the instance that we're working on. That's the one that we're testing features on, and then we have the instance that's stable that we want to show to our clients, that they want to show to other organizations to show their progress. That's sort of the difference that we at AArt sort of see. And when we're doing that, what we find helpful is having a sort of modular way of updating the backend, working on a backend, and then quickly deploying onto Secret testnet, or deploying onto Secret mainnet, and then building a front end that can quickly be either published, or it can be at least put in like really quickly onto a local machine. Does that answer your question? Sorry. That's sort of our experience at AR anyway.
Yeah, thank you. And I guess I'm curious, like, are you full-time Web3?
So I'm not committed full time to Web3 as yet. Um,
Mhm.
when we are expanding at ART, so we're hoping to eventually be full time. Um, we consist at the moment of three devs, none of which are full time, but that's something that in future with a bit more development and growth, and which is why we're also foraying into consulting so that we
Oh,
can
awesome.
we have more opportunities to do this full time, and more opportunities to sort of keep engaged with what's developing in the secret network in the development community.
Awesome. And how did ART come together? Is it strictly like secret projects, or are you guys developing in other ecosystems? What led you to want to like form, I guess, like a company to be able to do this?
We really think so. The way we sort of came together did start from the greater Cosmos community. It came from interest from Cosmos, but we've sort of, I guess, we've sort of made a bit of a foothold in Secret Network because it was, it's quite a novel thing to like have on-chain privacy and then also on-chain verifiable randomness. So there's a lot of things that you can do with that. So it sort of became like a natural place to start from. And to answer the second question, um, we sort of formed because well, there's a strong belief that we have that a lot of organizations in future will want to make a transition from Web 2 to Web 3, and there's a lot of benefits to be had from that transition. So obviously there's philosophical things like decentralization can be good, but then there's also there's there's benefits to certain businesses, things related to GDPR that actually this sort of platform or this sort of framework of doing business actually might be beneficial to them. And I imagine that's just like the tip of the iceberg. So the summary is that a lot of companies are going to start demanding Web3, demanding being a part of Web3, and they're going to need not only tools that are useful for Web3, so that their products can sort of transition seamlessly. Because most people they don't want like even when we're building our DApps, the idea is a person who's never heard of Web 2 or Web 3 will interact with our DApp and they won't really need to know. Like the benefits are there for them to look up, like they can look into why this is better. But the idea is that it's supposed to be seamless. A lot of companies, I believe, are going to want some help doing that, which is sort of why we go into labs, not only to do some research for our own, for ourselves, but also into consulting to help these businesses in future to make that transition.
Awesome. And I guess my last question is just kind of just thinking about maybe anyone who is a newer dev who might listen to this, who's new to the Web3 space. How long did it take for you working in Web3 for you to receive your first payment for something that you did?
Um, I think, well, I guess it would depend, but I think it took for me maybe definitely under a year. So I want to say like 7 or 8 months.
Hmm.
Most of the time it does take a long time to, especially if you don't have that familiarity already, to familiarize with core concepts, and you need to be certain that you like, especially if you're going to be building something and people want to pay you to do it, you need to know what you're talking about. You need to know where you're going because it's already quite a novel area, and you want to you want to produce, you want to set a good impression. So it does take time. It took like about and then within that there was some proof of concepts that I fortunately was able to have to say like, look, this is some stuff I've done before, to prove that actually I know what I'm talking about, and you can pay me to do that. You can pay me to build your project, your product. 8 months is what it took for myself. For some of so for our other colleague who sort of started at AR near around the time we formed, maybe I'd say the same 8-9 months. So you really can do it. Obviously, it depends on every developer. Some people take a bit more time, but it's definitely achievable for most developers. Well, for anyone if you're willing to do the research.
Very cool. Do you have any parting things you'd like to say before we conclude?
Passing things. Thank you for the opportunity. I, this was good for me because I've been quite busy with non-development stuff, so this sort of forced me to brush up again. That's quite good, and yeah.
Awesome. Well, thank you so much, and thanks for everything you're doing for the secret community. And just looking forward for users to get to play with your apps and then all the apps that are to come. So thank you so much, Aisha, for being here today and for speaking with us about AR. And yeah, for anyone who's listening, our hackathon, HackSecret 3, concludes June 20th. So feel free to submit up until then. And we're really looking forward to reviewing everyone's submissions. Thank you to everyone who is in attendance with this and for DoraHacks being such a great partner to work with for our hackathons. Thanks, everybody.
Bye.